Welcome back to the video. Today we're doing another LeetCode question. We're doing a medium 2130, the maximum twin sum of a linked list. So I wanted to make this video because I was kind of confused with it. The instructions aren't too bad, but we're just going to skip those. So we're giving the head of a linked list 5 points to 4, 4 points to 2, and then 2 points to 1. Easy enough. And then we're going to add the corresponding nodes together. The corresponding nodes are going to be the first one and the last one. 5 and 1 is 6. So right now we return 6 because that's the biggest number. Then we're going to move in 1 and then move in 1. As you can see, 4 and 2 are both in red, so we're going to add 4 and 2, which is also 6. 6 equals 6, so it's still 6 is still the biggest number, so we still return 6. The second example, we start at the first and the end. You see they're both blue. 4 and 3 is 7, so right now we're returning 7. We've got to see if there's anything bigger than 7. Then we move in by 1 and then move in by 1. 2 and 2 are both in red. We're going to add those up together. That's 4. 7 is greater than 4, so we just return 4. We start at the beginning, at the end, but there's only 2 nodes, so by default we just return they're like addition. Say there were 6 nodes, you would start in the beginning, at the end, move in by 1, and then move in by 1, and then see which one would be bigger, and keep going until we find the biggest one, or if we already have the biggest one, just return it. The reason this is kind of confusing is because they want you to reverse the second part of the list to help you find the answer. Which it does work, it's just a little bit more confusing. I did get it to work, but the way I'm going to show you is much easier. Because say you're at a job interview, you want to show them something you can understand, and you might forget the reversing part. So the way they want you to do it, they want you to use 2 pointers, slow and fast. Slow is going to get you to the middle of the list, which would be 2. Once we're here, they want you to reverse the second part of the list. So you could reverse 2 and then 1. So 1 will go where 2 is at, and then 2 will go where 1 is at. And then you could use the head. You could add the head plus where slow is at. But remember, since it reversed, the 1 would be here. So the 2 blues would be added together, which would give you 6. You can move over to the right by 1, and then move over to the right by 1. 4 would be here. Remember, since the list was reversed, the 2 would be here. So you would add up the 2 reds. You would get 4 and 2, which would be 6. Which it does work. It's just a little bit more confusing in my opinion. The way we're gonna use it, what we're gonna do is we're gonna use a stack. So we're gonna use the fast and the slow pointer, as I've kind of drawn it here. And then I have the list, and it's also color coordinated. And here's my poorly drawn stack. So what we're going to do, we're going to traverse until we get to the middle of the list using the slow pointer. Whatever is slowest under, we're going to add to the stack. So by default, slow and fast are going to be at head. So we're going to add that to stack. So that's a number 5. Let me see if I can make it look any better. Here, that's a tad bit better. So fast and slow pointers, you could use the fast pointer to like keep going until it's none, pretty much. Until the fast pointer is none or fast on next is none. Well, that's the case. Slow will be in the middle of the list. So fast moves over 2. So fast is right here. And then slow moves over 1. So slow is right here. So it's under the 4. So we're going to add it to the stack. And then we're going to move fast over 2. You might be saying there's nothing here. What's here is none. But our condition is, well, fast and fast on next is none. In this case, fast itself is none, so like it stops. So slow would be pretty much at the 2, which would be right here. But we're not going to add it to the list, to the stack. All we added is 5 and then 4. And then while that happens, we keep going until slow is none. So slow would be here. We keep going until slow is null. So slow is 2, and then we would pop 4 from the list. So it would be 2 plus 4, which would give us our 6. And then we move over slow by 1, so slow would be right here. 4 is gone, so we would do 1 plus stack.pop, which would be 5, which would be 6. Slow would be here, none, and then we're done. Our algorithm's finished. So let's actually code it up. So what I've been doing, I've been actually coding it up in like VS Code, because I could write it here and like in the built-in text editor in LeetCode, but sometimes I'm struggling and I want to see like what's in my variable. So I've been using the debugger. Kind of helps you learn. So we could say slow. There's a slow pointer is equal to head. Fast is going to be equal to head. If I could type. And then we're going to be using a stack. We'll call it just stack because it's simple. and then a variable called maxsum. We'll just set that equal to 0. So the first thing we want to do is we want to simulate, like how we did here, our fast and our slow pointers. As I said before, while fast and fast.next, so this is what we're saying, while they're both not null or none in this case, I come from a Java background. As soon as fast is none or fast.next is none, the while loop breaks and it just stops. And remember how I said as we're traversing it, we're going to add whatever's under slow to the stack. In this case, 5 and then 4. So we could do stack.append, and we're going to add in slow.value. And then we could just move the 2 pointers over. Remember, slow moves over once, so we could say slow equals slow.next. And then fast moves over 2 at a time, so we could say fast equals fast.next. So that's pretty much it. If we return slow, slow is going to give us, slow should return the number 2. So let's actually do it. Oh, not returns to 2. We're going to return slow.val. Because slow got us to the middle of the linked list. As we see, slow is 2, which is correct since we're right here. Okay, so now we're at the middle of the list in our stack. Let's see what's actually in our stack. So this is what I've been saying. I like using the debugger. So while fast and fast.next is not none, we're going to append whatever the beginning is to the list, which would be 5, or to the stack. You can see the stack is here. And we're going to move over slow. We're going to move over fast by 2. And you could even see the current value of your fast pointer. Fast is currently pointing to 2. Let's see if that's correct. We move over by 2. As you can see, it's doing what we expect it to do. And then we append 4 to the list, which is what we thought. And now it's none. So now it stops, and our slow pointer is in the middle, or in this case 2. Cool. So that's what we want. And now we can keep going until slow is none. And when slow is none, all like the numbers will be popped from our stack, and then we'll have like the max sum. So let's actually code that. We can say, well, slow, you could say is none, but Python knows this pretty much means is none. But I come from a Java background, so we could say, well, slow is not none. And then we can use our maxsum variable. Maxsum has that equal to the Python built-in function called max. And then we'll pass in maxsum. And we'll pass in stack.pop, which would pop the top number from the stack, plus slow.value. So this pretty much does what we did over here. Slow.value, I think we're looking at the number 2. So we're going to be adding 2 plus whatever's at the top of the stack. 2 plus 4 is 6. Then we're going to move over slow by 1. 4 is gone. Then we're going to add up the 1 plus the 5, which would give us a 6. Slow moves over to the end, to none. There's no more numbers in the stack, so it ends. But we are missing one thing. We have to say it. Slow, we have to move over slow by 1. Thought it would never move. Slow equals slow.next. That's it. And then we could just return max sum. And in the case of the LeetCode question, the answer should be 6. So let's run this. And the answer is 6. We're getting 2 because we returned slow in the beginning, cleared it out, and it's 6. What I like to do a test run. Like, let's see what our code is actually doing. So we know this gets us to 2. So we're saying, well, slow is not none. We could also say, well, slow, but I come from a Java background. We could say maxsum equals the maxsum, which would be 0. So we would compare 0 and then what the other number is. Stack.pop, which would give us the, what does stack.pop give us? It does the 4, and then slow is at 2, so it does 6. We move over slow by 1. Slow is still not none. And then we're comparing 6 to stack.pop. Let's go over to what we drew. It'd be 5. And then what is slow right now? 1. You can see the value, so you can actually see what's going on. So 5 and 1, it's going to give us 6. We move over, stack is empty, slow is going to be none. It returns the max sum and it ends just like that. So that's what you could do if you could actually see what your code is doing. So if you're having some issues, like, hey, why am I getting an error here? You can actually see it. And if we copy and paste our code over to LeetCode and just copy and paste it in, first run it, should automatically pass. It passed all the test cases and we'll submit. And then we beat 85% of people. Yeah, that's good. This is the way I was doing it, but there's another way. Remember I was saying how you could reverse the second part of the linked list, which it does work. I don't know if it's faster, I haven't tried, but I feel like this way is just a lot easier. Just get to the middle of the list, and then by the time you get there, you have your stack filled up. While slow is not none, you just keep popping the stack and keep getting the slow value, and then adding them together. While slow is none, everything from the stack should be like done with, and you're done. You just return the max number. So yeah, here's the code. If this helped you in any way, please leave a like and subscribe.